Welcome back, welcome back, welcome back. We are now ready for our activity. All right, so you're going to pretend that your marshmallow is an atom, that it is the interior of the atom that is positive. Your pretzels are the electrons where it's making a bond. So the pretzels are both what charge? Negative. Will they attract or repel? They're going to repel. So first we're going to start with two bonds. I want you to stick them into your atom as far apart from each other as possible and see what bond angles we're going to have. So do it and then hold it up so I can see how you arrange them. Did you do that? Okay. All right, so this would be linear, which is on your notes further down, but we'll just talk about it and then we'll write it. Okay, so now, what about if it has three bonds? Add a third pretzel. Add a third pretzel. Did I do it right? Did Samantha do it right? No, we didn't, did we? Can these two get further apart? Yes. Andres, hold yours up. No, yours is kind of like that too. I thought you had gotten it right. Somebody do it right and show it to me. Close. Somebody do it right. That's pretty good. Tucker, hold yours up. Hold it up high. It's the peace symbol. Make a peace symbol out of it. Make a peace symbol. Before, you had 90-degree angles and 180. Now you've got what angle? Y'all had geometry. What angle is this?
75. 90. No.
360 divided by 3. 120, yes. So these bond angles are 120, which is more than 90, isn't it? So now try 4. What about 4? I keep getting this curved one. I'll just have to eat it so that I keep picking it up. Try 4. Hold yours up, Max. Is Max right? No. What about if you turn it and make it an X? No. No, I'm leading you astray with mine. Somebody figure it out. How do you make it further apart? This is 90. We can go bigger than 90. There's a way to get to 109.5. There's a way to get to 109.5. Sounds like a radio station. No. Nope, that's still 90. That's still 90. Drew, hold it up real high. Let me see what you did. Turn it around. I think Drew's got it. Drew, what'd you do?
I left the 3 that we had and then just stuck one in the right center.
Okay, I think he's got it right. What you do is you keep one straight up, and then you make the other 3 come down like a stool. You got to think 3D. Atoms aren't flat, they're 3D. If you have them right, every time you turn it, it's the same. The bottom 3 are a stool, the top one goes up, and mine's not quite right. This is called a tetrahedral, and it is what carbon does, and it is the basis of life. Because carbon can do this, you're alive. And also because water is a polar molecule. And also because the earth is on the axis it's on. And because we're the third rock from the sun, and it goes on and on and on. But this is one of the things that we would not have life without this arrangement of carbon. All right, you may eat your lab equipment if you want to. You don't have to. Yes. And if you need some water, I've got little cups. You can get water out of the sink. If you need some water to wash down your pretzels.
Well, like the gamble.
The pretzels might make you thirsty. These pretzels are making me thirsty. Okay, I'm going to eat mine later. Put it in there with my Cheerios for a snack. All right, that was fun. Think y'all got it? So now we're going to talk about this next idea. See how far we can get. I would like to finish this up. I got to close up the food. Sometimes we have cockroaches. It's true.
It looks like the thing from Diary of a Wimpy Dude.
All right. Let's go on with our notes. Let's see if I can. Okay. So sometimes, remember when we did our electron configurations, say we did nitrogen, or when we did our Lewis structures. Nitrogen looked like that, didn't it? 2 on one side, 1 on each side. So nitrogen's got 3 electrons that are by themselves. That's where it's going to make its 3 bonds. Can you understand that? Because a bond is a pair of electrons. So nitrogens make 3 bonds. They have on one side 2 electrons that are already a couple. This is called a lone pair. They're drawn by 2 dots. Sometimes they'll draw a little bubble around it that makes it look like an alien head. That is called a lone pair. So lone pairs are unshared pairs. They don't make bonds at the lone pairs. They are unshared. And they are more negative. So, we're going to do a lab where we're going to be building these and looking at them. But nitrogen, even though it's got 4 places for bonds, it doesn't make an exact tetrahedral. Instead, this lone pair, being extra negative, will push these 3 bonds away. So it's not a perfect 109.5 on every side like carbon does. It's a little bit bigger than 109.5 between the lone pair and the shared pairs. And it's a little smaller than 109.5 between the shared pairs. Okay, did that make sense to you? Lone pairs are unshared, they're more negative, and they will push bonds further away. So we're going to do a lab activity with it. All right, I'm going to roll this up, and we're going to talk about the numbers I just said. I was telling you the bond angles, and now we're going to write them down. Okay. So for methane, these structures that we're talking about have different names, and you need to know what they are to be good at chemistry. So the first one, if we were going to do methane, it's Lewis structure. I want you to draw. You can draw it while I'm drawing it. Draw the Lewis structure for methane. You draw dots. The 2 dots is a bond. There's something called a molecular formula, and that's where you just write it shorthand. CH4. The structural formula, wherever there's 2 dots, you draw a line. So you have carbon, line, 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 with H's on the end. You've seen these before, haven't you? In the package insert for your drugs, it'll have the structural formula written out a lot of time, like legal drugs. Ones that come with package inserts. Not illegal drugs. But you'll see structural formulas. I have a shirt that's got the structural formula for caffeine, one of my favorite molecules. But it's a little tight in the neck, so I don't wear it much. It's one of my green science shirts. Okay, so if we had when we put our 2 marshmallows in, that structure is called linear. The bond angles are 180 degrees. So example is carbon dioxide is an example of one. And we're going to build these in lab and you'll see it. Trigonal planar is 120 degrees. The P sign is not called the P sign. It's not sciencey enough. It's called trigonal planar. Tri is 3, gonal, like you learned that in geometry class, like a pentagon. And then planar, it's in one plane. It's flat. It's not 3D. An example of that is SO3. Tetrahedral is our one with 4, and I told you it's 109.5 degrees. And our example for that is methane, CH4. Trigonal pyramid, this is the one with the nitrogen and the lone pair squishing them together. This one is 107 degrees between the bonds. So our example for that is nitrogen. Nitrogen bonded to hydrogen's ammonia. Did I tell you all the story about ammonia yet, how I got its name? No. Ammonia is an ancient chemical. It has been around since a very, very long time, used for, useful chemical. How it got its name was ancient Egypt. They had the god Amun-Ra. Remember that from history class? They would do human sacrifices to Amun-Ra. Makes me glad that that's not the prevalent religion right now. Nobody's going to sacrifice me to Amun-Ra. But they used to sacrifice people, burn them up to Amun-Ra. It would be outside, and their remains would be ashes. It would rain, and ash mixed with water makes ammonia. Ammonia has a very distinctive smell. They thought that smell was Amun-Ra coming to collect the souls of his offering people. So ammonia is named after Amun-Ra. Isn't that kind of gross? Now you'll see it in the grocery store and go, glad they don't make it with people anymore. Okay, Girl Scout cookies made with real Girl Scouts. No. All right, so here our other one is bent. Bent is going to be really less than 120 degrees. Remember, that's the less than symbol. The example for bent is SO2. And we don't know their names yet, so I'm trying not to use them. All right, let's go on to the next part. Sometimes they can share more than one pair, just like how parents can share more than 2 kids, right? If they share one pair, it's called a single bond. No talking, we're almost through with this. One pair is a single bond. What do you think 2 pairs is?
Double.
Y'all are brilliant. It's a double bond. What do you think 3 pairs is? A triple bond, yes. All right, let's roll up, if it'll let me. Please roll up, please let me. Miss Olivier? Oh, she's going to tell her the key seems to be lots of clicking. We were having problems with this before. I found out if you just go click, 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 click all over it, usually it lets you roll up. Instead of just one time, you have to really do lots of clicking. Okay, I was going to take it out. All right, so the net 3 pairs is a triple bond. Okay, now covalent, the way you name them is different. Remember with ionic, you name the metal, then the non-metal, change the ending to "ide." Or it's the metal, and then it's polyatomic ion name off of the chart. Or it's an ancient metal and you have to throw in Roman numerals or its Latin name. But covalent uses a whole different system. And it uses prefixes to tell how many. It uses prefixes to tell how many. So you need to learn these prefixes. So how many do you think mono is?
1.
1. How many do you think di is?
2.
How many do you think tri is?
3.
How many do you think tetra is?
4.
How many do you think penta is?
5.
Just like a pentagram, the pentagon. What do you think hexa is? 6, like a hexagon. Now this is the one nobody knows. Do y'all know hepta?
7.
7. Right, hepta is 7. How about oct? 8. Did I sing y'all the Flippy the Fish Head song about oct? How many legs do an octopus got? 8 legs. 8 legs. How many legs do an octopus got? 6 legs? No, 8 legs. 7 legs? No, 8 legs. That's how many legs an octopus got. It's a little counting song about octopus, but you can tell it's not teaching grammar because it uses bad grammar. But anyway, did any of y'all learn that song growing up? The octopus song? Okay. How many is non? 9 and deck? 10. Now, this is a little pet peeve of mine. They will say the city was decimated. What do you think that means? What? And that is not what it means. Des means tenth. So if a city is decimated, that means a tenth of it was destroyed. 90% of it's still fine. If an army is decimated, a tenth of it was destroyed. 90% of your troops are ready to fight again another day. It bothers me that people use that word wrong. So don't use it wrong anymore. Decimate does not mean to destroy. It means 1/10 has been destroyed. All right, so example of how you name this. You tell how many it has in its name with these. So CO2 is carbon dioxide. Di for 2, oxide for oxygen. CO is carbon what?
Oxide.
Monoxide. There's only one. The carbon monoxide will kill you. That's not an acid, but it will kill you. So then we're going to go back after our lab and list covalent properties. I don't want to lose the surprise. So just remember to go back. We'll pick up Monday with acid names. We'll finish these notes and hopefully do our lab. Like, share, subscribe.